All right, here are the notes for section 9.5. Just like before, I'm going to go through them kind of quick. Feel free to hit pause and take a break, rewind it so you can hear things again. But what we were talking about is, like it says, other angle relationships in circles. So basically, the idea is the location of the vertex of that angle. That tells us the different relationship between the intercepted arc. So for this first one, it's a little bit more specific. It says tangent and chord intersect on the circle, and that's the key part. They're intersecting on the circle. So we've actually already talked about this. It's called an inscribed angle. The angle is equal to half of the intercepted arc. So when you look over here at this picture on the right of the screen, angle 1, the vertex is on the circle. The intercepted arc is is this arc AB. So angle 1 is equal to half the arc. When we look at angle 2, same thing. Vertex is on the circle. The intercepted arc is this major arc BCA. So angle 2 is half of that arc. But it's because the vertex is on the circle. That's the key thing. So when we look at example 1 here, we're looking for the measure of angle 1. The vertex of angle 1 is on the circle, so the angle equals half of the intercepted arc. Again, the idea of that intercepted arc is it's the part of the circle on the interior of the angle. So that's arc AB. Oops. So for arc AB, that's 132. So half of 132 is 66. If I'm wrong with that mental math, then that's okay. You know what the right answer is. Same idea over here. The question is asking about the measure of arc EFD. So arc EFD is this whole thing. This 110 degree angle at vertex D, that's on the circle. So the angle is half of the arc. It's always the same relationship. So to solve for arc EFD, I'm just going to multiply both sides by 2. So 220 degrees is the measure of arc EFD. All right, that's how it works. The next relationship, when the angle is inside of the circle. Okay, so the vertex is inside the circle, and the key thing here is it's not at the center of the circle. It's just somewhere on the interior. So what we're looking at is this intersection over here at the right, where I got this blue dot. The center of the circle is somewhere over here. We're talking about the vertex just inside the circle, not at the center. All right, this one's a little bit convoluted, but it's kind of a simple idea. If we look at angle 1 right here, its intercepted arc, it's not really an intercepted arc, but when we look at that angle, it intercepts arc DC. We're also going to go with this angle's vertical angle and its intercepted arc. So when we talk about angle 1, it is the sum, it's half the sum of these two intercepted arcs. And it goes the same way when we talk about angle 2. Angle 2 intercepts this arc, and we go with angle 2's vertical angle and its intercepted arc. So angle 2 is half the sum of those two intercepted arcs. Okay, that's the relationship. When the vertex is inside of the circle, vertex of the angle is inside the circle, the angle is half the sum of those intercepted arcs. So again, looking at example 2. This angle X, the vertex is inside of the circle, so the angle is equal to half the sum, so I'm going to add, this angle's intercepted arc. So this 140 and angle X's vertical angle, this arc FJ. So we're going to add 140 and 112, which gets us 252, and we want half of that. So that's going to be 126. Okay, there's the measure of angle X. In example B, basically we're going to do the same thing. I'm just going to set them up. I'm not going to solve them. So for X, this angle X, again, the vertex of the angle is inside of the circle. the angle is equal to half the sum of the intercepted arcs. So for angle X, kind of following it out, it intercepts arc AC. And the vertical angle here is arc DB, which is 57. So you add those two up, half of that. For angle Y, same thing. Let me clear this picture a little bit, otherwise it gets too busy. Angle Y, vertex is inside the circle. It's going to equal half of the intercepted arc, which is the 148, plus the other intercepted arcs of the vertical angle, that intercepted arc, 70. Half the sum of the intercepted arcs. All right, the next one is when the angle is outside of the circle. Similar idea, but here is our angle measurement. Looking over here on the right, there's our angle measure. The vertex is outside the circle. When we follow this angle in, it's intercepting two arcs. We have this bigger arc, BC, and we've got this smaller arc, AC. When the vertex of the angle is outside of the circle, we take half the difference of the bigger arc minus the smaller intercepted arc. So looking at example 3, angle X, the vertex is outside the circle. So the angle equals half the difference of the intercepted arcs. Again, follow that angle out. We're intercepting arc JF, that's the 170, minus, because the angle is outside the circle, minus the other intercepted arc, which is the 72. So you do the subtraction, you get 98. We're taking half of that difference, so half of 98 is 49. That's angle X. All right. Example B, same thing. Vertex is outside of the circle. The intercepted arcs are the 118 and X. It's the same setup, but this algebra is going to be a little bit different. So the angle, that's the 24 degrees, is equal to half the difference of the intercepted arcs. So 118 is the bigger arc minus the smaller arc, which is our X. So we're solving for X. So it's in a different location compared to example A, but we just got to do a little bit different algebra. So what I'm going to choose to do, we could easily distribute the 1/2 into the 118 minus X. I'm going to go the other direction. I'm going to multiply by 2 on both sides. That gets me 48. The half times 2 cancels each other out. So we get 118 minus X. And we're looking to solve for X. So I'm going to add X to both sides. I'm going to subtract 48 from both sides. We get X equals 118 minus 48 is 70, I believe. There is the arc X. All right, you may want to hit pause on this screen. This is just a kind of a summation of the different things we've talked about with the relationship between the angle and the arcs of the circle. And it's all about the location of that vertex of the angle. When it's at the center of the circle, the angle and the arc are one and the same thing. They are the exact same measurement. If the vertex is on the circle, it's an inscribed angle, so the angle is half of that intercepted arc. If the angle, the vertex of the angle is inside of the circle, not at the center, we do half the sum of those intercepted arcs. And when that vertex is outside of the circle, the angle is half the difference of the intercepted arcs. Always larger arc minus smaller arc. Okay, so just a couple quick examples. Oops, almost pulled the microphone out. So example 3, part A, vertex is outside the circle. Angle X equals half the difference of the intercepted arc. So 170 minus 72. There's the setup. I'll let you finish solving it. Same thing with part B. Wait a minute. These look the same. We already did these problems. All right, we'll skip that. So here we go. Example 1. This is like the checkpoint. Question is, what's the measure of arc ACB? The vertex is on the circle. So the angle is half of the intercepted arc. This intercepted arc is, when we follow the angle out, it's all of this circle, this part of the circle that's on the interior of that angle. So that is arc ACB, the one we're trying to solve for. So to solve for the measure of arc ACB, just multiply by 2. That gets rid of the 1/2. All right, example 1, part B. The angle is inside of the circle. Now, this 52 is actually this angle right here. So we got to be a little bit careful with this. The angle that we actually want to deal with, because of the arc that we're looking for and the arc that we know, we want to be dealing with those two angles where the blue dots I just put on there are. So with a 52-degree angle here, this angle is actually 128. So vertex of the angle is in the inside of the circle. So that angle, 128, equals half the sum of the intercepted arcs. All right. And then the last one, the angle 26, it's outside the circle. So the angle is half the difference of the intercepted arcs. You follow this angle out, follow the angle out, the parts of the circle on the inside of that angle. So larger arc y minus smaller arc 30. To solve for y, again, I'm going to multiply by 2 on both sides. That gets rid of that 1/2. Now to solve for y, just going to add 30 to both sides. All right, that is it. Bye.